right. Good job on that first one in particular. Looks like we have some consensus. Let's talk through these problems. I think word problems are kind of fun because they show you what a lot of the stuff we've been doing with equations can actually be used for. I know these problems are a little bit like canned, but there have definitely been opportunities for me to use word problem techniques in real life situations. So we have a pretty simple setup for this first one. This is a geometry problem. It says Merida's garden has a rectangular shape. So that's a nice bit of information there. This is a rectangle with a length that is 1 foot longer than twice the width. A length that is 1 foot longer than twice the width. So we have some keywords in there. Longer than indicates addition. Twice indicates multiplication by 2, that kind of thing. We are told that the area of the garden is 55 square feet. So we're given some information about the geometry, about the area of the garden. And then we're asked this question: what are the dimensions of the garden? So what are the length and the width? This is our goal. The dimensions of this rectangular garden, length and width. So we don't know either of those. If I'm approaching a problem, then I usually like to make notes on what information I'm given, and then what is the information that I am being asked to find. This one looks like it would be helped by drawing a picture. I don't know if Anna drew a picture on hers, but I am a picture person, so I'm going to draw that. This is a rectangular garden. This would be the length. This would be the width. Okay. We are told that the length and the width have a certain relationship. We are told that the length, which we're going to call L, is or equals. Whenever you see that word is in a problem, that can indicate one thing equals another. The length is 1 foot longer than. Longer than can indicate addition. Twice the width. Twice means 2 times. And we have a variable representing width there. So we can see that there is a relationship here that we could set up between the length and the width. Go ahead and put that on my picture. 1 plus 2W. Okay. So we made use of the fact that this is rectangular. We drew ourselves a picture. We made use of that sentence that tells us the relationship between the length and the width. Let's make use of this next piece of information. We are told that the area of the garden is 55 square feet. The area of a rectangle is length times width. And I gave you several helpful equations to know about areas of certain figures. The area rectangle is probably the simplest. If we know that area is equal to length times width, well, area is 55. That's what we're told here. That should be equal to length times the width. Okay. So there is our second helpful equation here. We have this top one. This way that the length relates to the width, and then we have this area equation. Length times width is equal to 55. If I can somehow rewrite these two equations as one equation, with only one variable, then I can solve. So I'm going to use these two equations. L is equal to 1 plus 2W, and 55 is equal to L times W. Maybe I will take this top equation. I'll take what L is equal to, which is the 1 plus 2W, and I will substitute it for L in that second equation. So 55 is equal to the length, which we know is 1 more than 2 times the width times the width. Okay. Once we have an equation set up like this, that shows us the relationship it shows us how to solve, it gives us an equation with only one variable. I should say that. One variable. So I have only W in this equation. We can solve for that variable. So we can use all of our processes from the previous few chapters to get W by itself. And maybe I'll go over to the right here. 55 is equal to, I'm going to distribute the W over the parentheses. 1 times W is W. 2 times W is 2W squared, because W times W is W squared. This is a quadratic, so it has a W squared and it has a W term. If ever I see a quadratic, generally I want to get 0 on one side, everything else on the other side of the equation. That's what I'm going to do here. Let's subtract 55. And maybe I will rearrange the right-hand side and I'll put the W squared term first, then W, then the 55. None of those are like terms, so I can't combine them. I have to try to factor now. I have to use the key number method here. So I'm going to take 2 times negative 55. That gives me negative 110. Two numbers that have a sum of 1 and a product of negative 110 are 11 and negative 10. So I'm going to rewrite the middle term using those two numbers. 2W squared plus 11W minus 10W minus 55. Zoom in over here. And that will allow me to factor by grouping. I'm going to take a W out of those first two terms, and I get 2W plus 11, and then a negative 5 out of those last two terms. I'm left with 2W plus 11. So that gives me W minus 5 times 2W plus 11. I can set each factor equal to 0. W minus 5 is equal to 0, or 2W plus 11 is equal to 0, which tells me W is equal to 5, or subtract 11. 2W is equal to negative 11. Divide by 2. W is equal to negative, what is that, 5.5? Okay. Great. So we have solved for W. I'm now going to zoom out and look at the context of our problem. This problem was asking for the dimensions of the garden. So it was asking for length and width. Length and width. Okay. We let W represent one of those dimensions. It represents width here. I have two possible solutions. But this last one doesn't really make any sense. We can't really have a negative width. So I'm just going to, because of the specific setup of the problem, it's my variable is supposed to measure a length. I'm going to ignore any negative answers. I can't have a negative width. Therefore, my width must be 5 feet, in fact. So I have one of the dimensions I need now. Once I have the width, I can use that to find the length. Probably easiest to use this equation. Well, no, actually it doesn't really matter, but I think to me that equation is the easiest method by which I can find the length. We'll go here. I know that 55 is equal to the length times the width. Well, we just found that the width is 5. So to solve for the length, I'm now going to divide both sides by 5. And I get that the length is 11 feet. Okay, any questions on that one? Okay. And kind of some of the key elements of this type of problem are knowing some of these keywords that will allow you to set up the relationship between the variables here and here. Knowing your goal. So knowing what it is you're looking for. If you know your goal, then generally that's what your variables in a problem are going to be. I used W and L here for our variables. So I didn't use numbers for length and width because those are unknowns. I don't know what the length is and what the width is. I had to introduce variables here, L and W. Having some familiarity with, okay, if I have two different equations, how do I combine them into a single equation? How do I do a little substitution here to figure out how to eliminate one of the variables? Because I know how to solve an equation if it only has one variable. I don't really know how to solve an equation if it has more than one variable. And then being able to interpret down here, okay, which answer makes sense in context. Questions on that one? Okay, one more then. There's a geometry problem for you. Another type that section 7.7 covers is that of work. And this is a really good setup. We generally, when faced with a problem that involves a job that needs to be done or a task that needs to be accomplished, we can use this setup. The part of the job by one worker plus the part of the job by the second worker is equal to 1, or that one job that needs to be done. The jobs can come in different types. For this problem, it was a driveway that needed shoveled. So we're told a few pieces of information here. We are told that Brian, one of the, what we're calling workers here, can shovel the driveway in 30 minutes. That's one worker and his time, the time it takes him to do the job, do the one job. If his younger brother Alan helps, the job takes only 20 minutes. So that would be if both of them are working together. And we want to ask the question, how long So this is the key. This is what we might use as maybe our variable. Call that X. That's the part where we want to know. How long will it take Alan to do the job by himself? So we want Alan's time. We can set this up as part of the job by one worker. So that would be the ratio of, okay, how long does it take them to do the job together? And then how long does it take, say, Brian to do the job alone? To do the job alone. And what essentially that will give me is how much of the job did or could Alan have completed in a given amount of time alone? How much of the job, if they worked together, would Brian complete? Plus, same idea for Alan. We're going to take the ratio of his work, if they worked together, how much of the job would he complete together versus how much of the job would he complete alone? And then if we add the parts together, the part of the job completed by Brian, part of the job completed by Alan, that should give us the whole job because it says that they've completed the whole driveway. Okay. The part of the job completed by Brian, we're given that information. We're told that Brian can shovel all of his driveway in 30 minutes. We're told that Alan and Brian together take only 20 minutes. Oop, I mixed those up, didn't I? I apologize. Together should be on top. Together, they can complete it in 20 minutes, but alone, they can only take, Brian takes 30. If Alan and Brian work together, again, the job takes 20 minutes. We are asked to figure out how long it would take Alan to do this job by himself or to do the job alone. So that's where my variable comes into play. That's where X is. And then this should equal the entire job, one job. Okay. So the hardest part about these usually is setting up the equation. So this is my equation. My work equation. Once I have my equation set up, I can solve for the variable X. This is a rational equation. So we solve those by figuring out what's our least common denominator. In this case, that least common denominator is 30x. So I'm going to multiply all terms by 30x times 20 over 30. I think perhaps Hannah simplified this before she multiplied, but it'll work if you don't. 30x over 1 times 20 over x is equal to, and then we don't want to forget to multiply the opposite side by that least common denominator as well. We can't just multiply one side. Okay, I can now cancel my common factors. Looks like the 30s cancel here. Looks like my x's cancel here. Doesn't look like anything cancels on the opposite side. On the left-hand side, we have the x and the 20. 20x plus 30 times 20 is 600 is equal to 30x. Okay. Now this is a linear equation, so I am going to note that I have x terms on opposite sides. So I want to remove that 20x from the left-hand side so that I have all of the x terms on the same side of the equation. And now to finish up, to isolate x, I can divide both sides by 10, giving me that x is equal to 600 divided by 10, which is 60. And we have said that X is a measure of how long or the time. So this must be in minutes.
So if you hold on, what? If you do okay, so 1/1, that one, wouldn't you do 1/1 times 30 over X?
Yes, you could do it that way.
So, but if you do it that way, then you cross out the 30s.
You wouldn't cross out the 30 because the denominator of the 30 is 1.
Oh, yeah. Okay, okay.
So that's a good thing to check.
Okay, but okay, 30 over X, and then
Uh,
1/1. I put
Mhm.
30. Okay.
Mhm.
Okay, I got you.
Yeah, so it'd be 30x over 1 and then 1 over 1.
Yep. Okay.
Yep. Okay. Other questions about that one? All right. Are you sure?
Twenty X.
Okay. Sounds good. Well, let's do this then. Let's do a little bit in breakout rooms. We're about 5 minutes past what I had intended, but that's okay. So maybe we'll just do 10 minutes in breakout rooms, and then we'll gather back together and do 20 minutes together. Let's see. Let me create those breakout rooms. And there you go. You should see it pop up. Should take about 10 minutes. See if you can work through. Oh, I need to tell you what you're doing, don't I? Let's see. 11, 21, and 27. Work on those homework problems. I'll post this in your breakout rooms too. This should be 7.7. I apologize.
Okay, so can you send me another breakout room? Because I went into it and had to go back out so I could hear your direction.
Okay, don't jump in just yet. I'm gonna kind of switch things around.
Okay.
Okay, you should see something pop up now and can join.
Okay, so go ahead and go into the room.
We'll work on these about 10 minutes. Let's see.
Ms. Griff, I have a question. Uh,
What's that?
on, on number 11,
Mm-hmm,
is it the one that says difference of reciprocals?
mm-hmm.
Okay,
Yeah, that's the one.
okay.
Hello, everybody. Welcome back. Sorry, that was a shorter breakout room than normal. I'll wait a few more seconds for people to jump in. Okay. And there is a poll for those questions that you're working on. So hopefully you got to at least a couple of them, one or two of them, and can answer these questions. Let's take like 3 minutes for you to respond to this poll. And just answer the ones that you got to. You don't have to necessarily worry about getting the right answers for all of them, but hopefully you did for some of them. And I have one of my fractions is flipped on the solution. I apologize. So the correct answer for number one is it's close, but not quite there. So do the one that's closest to what you got. Oh, I take that back. No, it is correct. There's no mistake on that poll. What am I saying? All right, 15 more seconds. I know we're not taking long on this. I'm not anticipating that you got to all of them in your breakout rooms. Just do your best to answer the ones that you're able. Okay. And that it looks like a lot of people were able to get to the first and the last problems, so that's great. So we'll definitely spend some time talking about the first and second problems, and then if we get to the third, then we get to the third, and if not, it's okay. Because it's a lot like one of the ones we did before class or before the breakout rooms. Okay. So another common type of word problem is describing how different numbers are related. So this is one example of that. And for problems like this, I generally like to use X and Y for my variables. So this will say things like one number and another number. So I'll let X be one number, I'll let Y be another number. You don't have to do things like that, but I a lot of times like to do that. And then we're told something about how these numbers are related. One number is 9 times another number. And then we're told that the difference of their reciprocals is 1. So we're told 2 different ways that these numbers are related. And some people prefer to set up 2 equations and then put those 2 equations together. Some people prefer to just set up 1 equation. I tend to lean towards 2 equations. So let's do it this way. One number is 9 times another number. So let's let that one number be X is 9 times another number. That number is Y. I don't want to call both numbers by the same variable or they would have the same value. So that's one equation. The second piece of information we're given is that the difference of their reciprocals is 1. So if I take, say, 1 over Y minus 1 over X, I will get 1. So difference means an answer to a subtraction problem. So I put subtraction because of that word difference. And then the reciprocal means the flipped fraction. So that's how I could set that up. Another way that I could interpret this is, okay, now let's put these equations together. Instead of writing 1 over X, I could write 1 over 9Y because I know that X is equal to 9Y. So I could replace it with that. And that is equal to 1. Okay. Questions about that setup so far?
Yeah, I'm totally lost on this one, but the thing about it is these homework problems, like you don't have no other way of going back and working through them. So I'm just confused how you got from 1Y and then the difference over 1X equals 1. Where did the 1 come from? Where, okay, so
No, that's a great question.
So 1 is the reciprocal, right?
The difference, we're told that the difference between the reciprocals is equal to 1. So that means that if I subtract one reciprocal from another, I should get 1. So that's where the equals 1 came from. A little bit of terminology here. The reciprocal of X. Oh, come on, little pen. The reciprocal of X is 1 over X. So if you want to find the reciprocal of any number, you can note that, okay, the denominator of this is 1. We can flip the fraction and we get 1 over that X. Similarly, the reciprocal of Y is 1 over Y. Difference means the answer to a subtraction problem. So there's a lot writing on this one sentence. The difference of the reciprocals is 1. So I'm going to take those 2 reciprocals, set up their difference or their subtraction here. And we're told that if I do that, then the answer should be 1. That should be equal to 1. Okay.
Okay, so then where do you get the 9Y from then? You just bring the 9 from the X up over there?
Mm-hmm.
Okay.
Yep. Anytime that I want to solve an equation, I generally want to only have one variable in that equation rather than two. I set this up originally with two variables, but then I want to combine the two. And note that, okay, this 9y, I could replace my x with that because I know that x is equal to 9y. And then that will give me an equation with only one variable, which I can solve.
I'm still confused.
Okay, so once I have that equation set up, this is a rational equation again. So I can note that my least common denominator is, well, there's a 9 and there's a y. So those must both be involved in my equation, or in my least common denominator rather. I'm going to multiply all expressions by that least common denominator. 9y over 1 times 1 over y minus 9y over 1 times 1 over y, 1 over 9y rather, is equal to 9y times 1. Okay. And now I can note that these y's will cancel, but the 9 remains. Both the 9 and the y will cancel in that latter expression. And then 9y times 1 is 9y. So we've gotten rid of our fractions. I can now simplify this. 9 minus 1 is 8. 9 times y is y. To solve for y, one of my numbers, I'm going to divide by 9. So that gives me 8/9 is equal to one of my numbers, that number being y. Okay, so I have one number, y is 8/9. I can now use the fact that x, my second number, is equal to 9 times y to find my other number. X is equal to 9 times y, which is 8/9. I have this nice property of a 9 on top and bottom. So what remains is 8 on top. Okay, questions on that one? I know that one had a lot of pieces, a lot of terminology, stuff like that.
So why did you put the x 9 equals 9y over there? And
I did that because once I found my,
is this the check?
well, we're asked to find two different things here.
Okay.
We're asked to find two numbers. I called those two numbers x and y just to introduce some variables. I found y on the bottom right. I still needed to find x.
Okay.
So in order to do that, I can use what we said originally, that x was equal to 9y, because one number is 9 times another number, to determine what my second number x is. So I can substitute what I know about y, and that gives me x.
Okay, so you use, okay, I see what you did. And then you checked it. That's the check.
I haven't checked it yet.
So what is, so when you do the x minus, okay.
Yeah, I haven't checked it yet. I was just finding that second piece of information. I think we're out of time. So like normal, happy to stick around if you have other questions, but I don't want to hold you any further. So I'm glad we got to do a few of these at least. I do recommend that you watch Hannah's video. She goes over a bunch of word problems. Okay. Other
Nine.
questions?
So that's 9 times 8, 9 over 1 times 8 over 9.
Yes. Yes, that is what that is.
And so then you divide, right?
You're going to, I canceled the nines because I have a 9 on top and a 9 on
Oh,
bottom.
okay.
So that leaves me with an 8 over 1.
So you don't have to, okay.
Yeah, you could just multiply. You could take 9 times 8 and then 1
Yeah.
times 9, but then you end up
Yeah.
having to
You're
reduce.
still gonna get the same thing, yeah,
Mhm.
okay,
Yep, exactly.
okay, thank you,
You're welcome.
I get it.
Great. All right, other questions? Are those of you hanging around? Do you want to go over that second problem? Or do you want to pause?
So the x would equal 8, right?
X is equal to 8, yes.
Right,
Mhm.
so the other one would be y is equal to 8 over 9, and then this one would be x is equal to 8. So,
Or, you know, I created the variables X and Y, so I don't necessarily use those in my answer. I would just say one number is 8/9, the other is 8.
okay. So do you wanna continue with the 21 or?
I can, if you want me
Okay,
to.
because honestly, I was confused, so.
That's okay. We can totally do that. Give me 1 second to send a text or a message, and we can do that one. All right. So Eleanor traveled 600 miles by commercial jet from Kansas City, Missouri to Spokane, Washington. She then traveled an additional 400 miles, or 500 rather, on private propeller plane from Spokane to Billings, Montana. If the speed of the jet was 4 times the speed of the propeller plane, the total time in the air was 6 hours. And the total time in the air was 6 hours. We want to determine the speed of each plane. Okay. So some key words, key terms here are, this compares speeds and rates, or speeds and distances and times. So for anything involving speeds, distances, and times, we want to remember this relationship, that rate or speed times time is equal to distance. That's kind of the overarching relationship between those three that we want to use for this. Hannah organized her information on a table, and I think that's a good idea for these types of problems.
Is that rate times time equals distance, right?
Yes, that's what that is.
Okay, gotcha.
Okay.
Hannah, where did she organize it at?
When she explained these on the videos, she
Okay.
used tables for these types of problems.
Okay.
Okay. And I'll go ahead and write this out. We're going to use, let's see, we're given information about 2 different trips, so I'll have 2 rows. One of my columns will be for rate, another will be for time, the other will be for distance. And maybe I'll make that top row the information for traveling on the jet from Kansas City to Spokane. And then that last row will make the propeller plane information. And then that'll help keep it organized. The distances we know for sure. we are told exactly, say, the distance traveled on the jet, and that is 1,600 miles. And we know exactly the distance traveled in the propeller plane, and that's 500 miles. Okay, so we can go ahead and insert those into our table. I like, as I think I've mentioned, to make a note of what I'm being asked to find. It looks like we are asked to determine the speed of each plane. Speed and rate, same idea. If we know we're being asked to find that, we know we don't know the value of that. So maybe I'll call that X. I'll call the thing that I'm being asked to find X. Okay. Let's see if I know any other information about speed. It looks like the speed of the jet, oops, not do that. Looks like the speed of the jet was 4 times the speed of the propeller plane. So if I call the speed of the propeller plane, what if I call that X, that means the speed of the jet is 4 times that, or 4X. So I could at least put something in my table to represent those two quantities. Does that part make sense? Okay. The time, we also are not told. The time is, we're told the total time, but we're not told about the individual times. So I'm just going to make this note on the side. Total time is 6 hours. And rather than introducing a second variable, rather than saying, okay, let's let the time be y, I'm going to use this equation to make a representative of time. We can note that if rate times time is equal to distance, then if I divide both sides of this equation by the rate, I get that time is equal to the distance over the rate. Well, I have a rate for the jet and I have a distance for the jet. So that means we could represent time by the distance over the rate. So I could take that distance, divide that by the rate.
Excuse me.
Uh-huh.
The formula that you're setting up, where are you getting the formula?
That rate times time equals distance?
Yeah, so is this a formula that you're building, or is there a rate? Because I know that there's certain formulas for like area that, and all of that.
Mhm.
But
Yeah.
so for this, is this the regular formula for rate times
It is.
distance?
It
Okay.
is. Yes. Anytime you see a problem involving speeds and times and distances, this is the formula you're going to use. There is not another one.
Okay.
Yeah, good question. Sometimes you'll have to rearrange it. So that's what I did here. I'm rearranging it. But it comes from that same basic formula. Let's see, where was I? Oh yeah, propeller plane. We can also take the distance, divide that by the rate. Okay. And that's just so I don't have to create another variable. I already created a variable for the rate because that's what I'm being asked to find. Not really being asked to find time. So I'm going to try to avoid creating another type of variable for that. Just going to use the relationships that I have.
So why do we have the T if we're not going to try to find the time?
Because we are given some information about the time.
Okay. So we have to input it. Okay.
So we're going to have to use it somewhere. Yeah.
Okay.
We're told that the total time is 6 hours.
Okay.
That will allow us to kind of put together the information that we have. So we've kind of put all information on our table except for that total time. We can
Right.
use the total time to create an equation using the information on our table. If the total time is 6 hours, then that should be the time on the jet plus the time in the propeller plane. We add those together, we should get 6 hours. Well, we've said that the time on the jet can be represented by that 1600 over 4x. And the time in the propeller plane can be represented by 500 over x. That should give me 6 hours if I add the 2 times, one for each trip. Okay. Does that part make sense?
Yeah, yeah, I'm staying with you right now.
Okay, sounds good. Just want to make sure before I move on. Once we have the equation, we can solve it. Again, half the battle with applications is just figuring out what the heck do I write as an equation. But once we have that, we can go ahead and solve. Oh, I don't want that. Let me create a little more room here. Okay. We're going to solve this using the processes that we've done before. A lot of these are rational equations. So we're going to find the LCD, which is, we could use 4x, that'll work. Which means I'm going to take 4x over 1 times 1600 over 4x plus 4x over 1 times 500 over x. And then that has to equal 4x over 1 times 6. I have to multiply the opposite side too. And that 6 doesn't, the 6 has a denominator of 1, so I'm not going to worry about writing the denominator for that one. These 4x's will cancel. The x will cancel. So that leaves me with what? 1600 plus 4 times 500 is 2000. I don't have any x's remaining on the left-hand side. Is equal to 24x, it looks like. 1600 plus 2000 is 3600 times 24x. Divide both sides by 24. That gives me 3600 divided by 24. I don't know what that is. So let's calculate that. So it's 150. 150. Let's see. 150 is a speed, it looks like. That's what we use to represent the rate of the propeller plane. So it must be in miles per hour. I don't think you'll be asked to use units here. But sometimes it helps to have an idea of what you just found. Does that make sense?
Yeah, well, I'm still multiplying, so yeah, I got it.
Okay.
150. So 150 miles per hour. Okay, yeah.
Yep.
So x equals 150. Yeah, I got that.
Okay. So that's the speed of the propeller plane.
So it's once you get the equation, it's not that hard.
Right. Yeah,
It's
finding the equation is the hardest part.
Yeah, it's trying to put everything together and find the equation. That's the hardest part.
Mm-hmm.
Okay. Do you want to do 27 or you gotta go?
I think we could do 27 pretty quickly. Because it's another work
Isn't there
problem.
a second part to that problem though? Aren't we supposed to
Yes,
talk
you are
about-
correct. There is. Thank you, Kira. Good catch. So we found, we're asked to find the speed of both planes. So you just found the speed of the propeller plane. How would you find the speed of the jet plane?
So, okay.
So the speed of the jet plane is 4 times that of the propeller plane. So it'd be 4 times that 150,
Oh, okay, got it.
which is 600. Usually once you find one of the quantities, the other one is not too bad. It's setting up your initial equation and then solving for that initial quantity.
So the 150 would be, okay, the jet was 4 times the speed of the propeller. So the jet was 600
Mm-hmm.
miles per hour.
Mm-hmm.
Okay. And the propeller was 150.
Yep.
Okay. Okay. That was a good catch.
Mm-hmm.
It's I wanna. Okay. Okay.
Okay.
Yes, ma'am. So
Great.
you're 27. Do you
Yep.
want to do that one or okay?
We can do that one. This one's not as long. This is another work problem. So we did one similar to this from the video. So we're told that Eric can paint a room in 60 minutes. His brother Jessup can paint the same room in 40 minutes.
Okay.
Okay, we're asked how long. So that's our clue here.
How long
How long?
take them?
So we're asked to find the time that it will take them to work together in the paint room. So X is the time that they are working together. If we want to set up a work equation, then we are going to set it up as their time working together over, say, Eric's time working alone. Eric alone. Plus, again, their time working together over Jessup's time alone. That should be equal to the entire job, which is one job, painting one room. And again, anytime you see an equation involving different speeds at which someone can do something, so different jobs, different speeds at which jobs can occur, different workers doing the same job, this is the basic setup that you want to use. Now let's fill in the numbers that we know. We said that X is their time working together, so X will go on top here. We are told that Eric can paint the room in 60 minutes. Again, we're letting X represent their time working together, so it looks like X is involved twice here. We are told that Jessup can paint the room in 40 minutes. And that's equal to 1 still.
So will we find the LCD right here?
Mm-hmm. Find some sort of common denominator, which I think is 120.
20.
Mm-hmm. So we can multiply everything by that. Divide by 60, here we get 2. Divide by 30, or by 40, we get 3. So it gives me 2x plus 3x is equal to 120. 3x plus 2x is 5x. Is equal to 120. And then,
Okay, so I didn't get, hold on, wait. Why did you did 120? Why did you do 120?
because that's the least common denominator.
Why would 120 be the least? Because I use 20.
When you are looking for the least common denominator, you're looking for something that both 40 and 60 will evenly divide. So something that they'll go into, not something that is a factor of 40.
Okay, so I'm factoring. Okay,
Mhm.
okay.
So 20 would be probably the greatest common factor. of
That would
those
be
two.
the greatest
Mhm.
common. Okay.
Mhm.
20. Okay. So that
Kind
does
of doing the opposite of factoring.
okay. So let's see. 60 is 1. 50. 120. Okay. So 2x plus 3x equals 120. Okay. So 5x equals 120. Cancel out the 5s.
Mhm.
5 divided x equals 120 divided by 5 is 24. Okay, 24.
Yep. So they can do this painting job together in 24 minutes.
Okay. Okay. Thank you so much.
Yeah, you're welcome. You are welcome. Okay. All right, Kiara.
Yes, ma'am. Hold on.
Okay. Let me do this. Let me stop my share here.
Okay.
And then I would love to be able to give you the points back for this. I just know from my end, all I see is a blank test as submitting. So if you can show me that when you submitted, that it's showing your work, then I would love to be able to give you that. But let me allow you to share your screen.
And then I had another question. I
Okay.
was also trying to see because I don't want to lose points because I'm having issues with submitting my work. So I was also trying to see if it's okay if like on exam days I would go to the library and do it there and just turn it in and submit it that way. And that way it's there, you can grade it, you can see it. I don't mind using the gas money to doing it
Right.
way. It's just I don't want to fail this class, like, and then have
No,
to pay
totally.
for it. I'm on probation watch. So
Totally. That is something that you would need to talk actually to your regular instructor about because she is going to take over before the next test. So she is coming back on Monday next week.
okay.
So her email is posted on the front page of our Canvas. So I would recommend that you just message her. My guess is she would be fine. Are you talking about like doing it at the testing center?
Yeah, or if I can do it at the testing center, I can like take the test at the library and then I can what I was saying, I could take the test at the library, then turn in the work to her within the 2 hours. Like
Okay. Okay. My guess is that'd be fine, but again, you'd have to talk with her about the specifics for that.
Cause look, I'm barely hanging on in one class. This is the class I should have an A in. Or a B. I'll be working hard in this class.
Mhm.
I'm trying to pull up my email, my student email.
Okay. If you submitted the same document in Canvas, you should be able to see it in your Canvas gradebook too. But either
Okay.
way, because I know that you sent me an email. I know I received that email.
And when I go in my downloads, it's saved under a PDF, and see, it says it's a PDF.
I did get a PDF, but try opening the PDF.
Let me see.
I think it's at the bottom.
The bottom of it.
Mhm.
This is just the questions. Is that what you seen?
That's what I got.
Okay, and then the whole test paper. So it should have I scanned everything in and sent it in. That is okay. So Miss Hannah will back Monday, so I'll be able to ask her like about a grade max. I have proof I've done it. It's in my computer and stuff. I have proof that I used to scan out and scan it. I don't know why I didn't.
Right. You can totally ask her. Yes. And I'm really sorry
Okay.
that it's tech issues that are kind of causing the problem here. Because I mean, I've seen how hard you've worked. I think you could do really well in the class. For this, note also that at the end of the semester, your final exam will replace your lowest score.
Both
So,
for both exams or just the first one?
whichever one is lower.
Okay. So they wrote, so I was still a 0 for one of those, but not for both of them.
But not for the first one. Correct.
Okay. Alrighty, well, thank you.
Okay.
And, if you could put in a note for Miss Hannah's, like, because I should have her word too, since she's been seeing progress. This is really technical issues that's causing me to this class. I'm crying. I'm just frustrated. Like,
I understand. It's frustrating when things like that hamper your progress and you really worked hard and tried. Like do you have the email with your PDF saved that has timestamps on it?
I have okay in my downloads, cause let me see what I have. In my downloads, it should be time step. Like this is the whole test. I have the whole first and the second test on in my download still because this is what the PDF came up like
That's the
after
can
I
scanner one.
yeah.
Okay.
So
I
I
don't, is there a timestamp on there? Or does
I
your,
might have to look on my phone, but I can't
okay,
see.
okay.
I can see.
Send me that and send me a screenshot of the timestamp for this. Okay? And I will
Okay.
see what I can
Yes,
do
ma'am.
with Hannah. Okay?
Okay, and I will be there. Well, I'll be in class every day, but I will most definitely talk to her Monday because this is really frustrated. I just rather do it on paper and just give you guys the paper at this point.
I understand. Yes,
All
nobody
right.
likes tech issues when they come up,
Man,
especially when it's something that affects your grade like this.
because I understand why I'm failing chemistry. Chemistry is hard. I shouldn't be failing math over technical issues, and I'm doing all the work. It's crazy. Well, all right. Well, thank you so much.
Yeah, you're welcome.
And I will send that to you and try to find the timestamp as well.
Okay, perfect.
All right. Thank you.
Sounds good. Have a good day.
You too. Bye bye.